Hello.
Hello, sir.
Yeah. Can you hear me?
Yes, sir.
Were you able to do those two questions?
Yes, sir. Um,
You got
the
it.
yes, sir. I didn't check the answer though. I just solved it.
So, first one was basically alpha and beta are roots of
X square minus X minus
uh,
1.
equal to 0, and alpha was greater than beta, and they had defined a thing called an, which is alpha power n minus beta power n by alpha minus beta.
Right.
And they had also given some b's. B1 is 1 and bn
Hmm.
is an minus 1 plus an plus 1
Yeah.
for n greater than equal to 2.
Hmm.
Then which options did you get? First option was what?
A1 plus A2 plus so on till an is equal to a n plus 2 minus 1 for
Hmm.
all n greater than equal to 1. That was, I got it, that's correct.
So how did you do that?
Sir, it's kind of like it's the Fibonacci sequence. So I've just I checked it like with some.
What do you mean?
It's like
You need to have a proper method of doing it. No, you can't just fluke it. You can
like
find the roots of this if you want, but finding the roots doesn't help us much.
it was like for each term in the sequence, it's for n greater than 3. It is a n is equal to a n minus 1 plus a n minus 2, and
Right. So how did you prove that?
proof. Well, I
The point is, how did you come up with that? How did you know this?
Yes, sir. I use like a sum of roots and product of roots when finding a1, a2, a3. So for a2 was like a square minus b square by sorry alpha square minus beta square by alpha minus beta. So I
Mm-hmm.
opened it as like alpha plus beta by into alpha minus beta by alpha minus beta, and that became sum of roots. And then for a3, it was alpha minus beta whole cube
Hmm.
plus 3 alpha beta into alpha minus beta. So alpha minus beta got cut everywhere, and it became uh,
Okay.
like
So you saw A1 was equal to 1 and A2 was equal to this, and this was alpha plus beta was 1, right?
one.
And this you can calculate now because you know alpha plus beta is 1 and alpha beta is minus 1.
Yes. So we
Okay,
can do
so,
that subsequent.
so you'll get alpha plus beta whole square minus alpha beta. So 1 minus minus, so plus 1 is equal to 2.
Two. Yeah.
So you're getting this. For A4 also you can possibly check by doing this calculation.
Yeah, you can.
You can cancel one factor and A4 would become alpha minus beta will get cancelled. You will be left with alpha plus beta and alpha square plus beta square.
Yeah.
So this also can be calculated. This is 1 and this is going to be alpha plus beta whole square minus 2 alpha beta, so 3.
Yes.
Okay,
And
so basically you are getting a pattern Fibonacci.
yes, yes.
Okay, then you figured out that this is equal to this.
Yeah.
You can see that's okay. What you have done is correct only. It's just that you can do it in general also. If you guess that that is the reason, then you can just check an plus 2 and check whether it is equal to an plus 1 plus an, right?
Right. Yeah.
By putting it in the expressions and not finding values, you can check it by putting it in this expression, right?
Yes, sir.
So that is also a possible way. Like it's not difficult to verify this. Once you
Hmm.
verify this, then you will automatically know this pattern, right?
Yes, sir.
Option B and option C were some infinite series, right?
Yeah.
So did you get anything about B and C? Which one is right? Which one is wrong?
Yes, sir. It's B is right.
B is right, C is wrong, and option D now.
Option D. Yes, it's correct.
That is also easy. Only you just have to put it in this now.
Yes, sir.
You put this expression into it and see what it comes out, right?
Mm-hmm.
and it will come out as, you can calculate it and see what comes. And after that, you just have to solve it.
Yes, sir.
Are you sure you have no problem with this question?
Yeah, I didn't have any issue.
And the next one, JEE 2017 one.
Um, P plus 2Q was on 12. And
Okay.
A12, did we have to find the value or something for
So there
A12?
were two parts of it. One was P plus 2Q, and the next one was
A12.
A12. A12 was supposed to be given in terms of the lower numbers.
Oh, okay.
You don't have to find the value because that will take a long time, right?
Yes, sir. That's
Did you get an expression for A12 or a pattern by which you can say?
no, I can try right now.
So you should be able to do it. It is going to be A11 plus A10.
Okay.
Uh, the reason it works is, uh, in the previous question when you did it, uh, let's see what comes. So previous question was about P and Q, right? Right.
Yes.
And the equation was the same equation, x square minus x minus 1 is 0. Alpha, beta were the roots. And an was defined as p alpha power n plus q beta power n, right?
Right.
And you are asked A12. So we need to get a sort of pattern here. So what you should do here is, this is a standard method, okay? So uh, this method you should be aware of. So what we do is, we say alpha beta are the roots. So we can write alpha square minus alpha minus 1 is 0.
Hmm.
We can also write beta square minus beta minus 1 is 0, right?
Yes, sir.
Now, I want to create terms like alpha power n and beta power n, right?
Right.
So what I will do is, I'll multiply this equation with the required power. I need to multipy it with alpha power n minus 2, right?
Yes, sir.
And here also I'll multiply by beta power n minus 2, right?
Right.
So these two equations will start looking like alpha power n minus alpha power n minus 1 minus alpha power n minus 2 is 0. And this will be beta power n minus beta power n minus 1 minus beta power n minus 2 is 0, right?
Right. Yes, sir.
Now you write it like this: alpha power n is equal to alpha power n minus 1 plus alpha power n minus 2, and beta power n is equal to beta power n minus 1 plus beta power n minus 2. And then we just construct it according to the way we are supposed to do. So for that, I need to multiply this equation by p and this by q, right?
Right. Right.
This by p, so everywhere p will come, and this by q, so everywhere q will come, right?
Yes, sir.
And now we add the two equations, you will realize that left hand side is an, right?
Yeah.
When you vertically add, this is clearly an minus 1. And this is what? This is an minus 2, right?
Yes, sir.
Do you understand? It's simple only.
Yes, sir.
From the original, so, but this method, you should know that if you need higher powers and things like that, usually we put the roots in the equation and generate those powers by multiplying with powers of the roots.
Okay.
So this method is very common and you should know it. So we got the alpha power n that we needed by multiplying these true equations, right?
Yes, sir.
And then we combined it after putting a p there and a q here, because that's the kind of term I needed to make, right?
Right.
So from here we will get that A12 is equal to A11 plus A10.
Yes, sir.
And that is basically the answer. Okay.
Right. Yes, sir.
Uh, okay. Next one. Next one is minus pi by 6 is less than theta is less than minus pi by 12. Suppose alpha 1 and beta 1 are roots of the equation x square minus 2x sec theta plus 1 equals 0, and alpha 2 and beta 2 are roots of x square plus 2x tan theta minus 1 is equal to 0. Okay, now they have said, if alpha 1 is greater than beta 1 and alpha 2 is greater than beta 2, find out alpha 1 plus beta 2. And the options are like 2 times sec theta minus tan theta. B option is 2 sec theta. C option is minus 2 tan theta. And D option is 0. So basically, they have given you this information about theta and given you two equations with roots alpha 1, beta 1, and this inequality on the roots.
Right.
And you have to figure out basically alpha 1 plus beta 2.
Yes.
Try it out. This is JEE 2016. It's not difficult at all. You just have to do normal common sense stuff.
Hmm.
See, this information was given to for you to identify which quadrant it is in, theta, right?
Right.
Because that will tell you the sign of tan and sec and whatnot, right?
Hmm.
These equations can be solved by direct formula, right?
Yeah. Trigonometric formula.
This thing is there to tell you which root is which one.
Right.
Because there are two roots, right?
Huh.
So यहाँ पे formula अगर if you use, what will happen? Alpha 1 comma beta 1 would be what? 2 sec theta plus minus root over 4 sec square theta minus 4, right?
Huh. Right.
Now by 2, right? So
Hmm.
now if you think about it, this is going to be 2 sec theta plus minus root over 4 tan square theta divided by 2, right?
Yeah.
When you take root over square, what should I write here?
One second.
When
Simple.
you say root of x square, what should I write?
X.
No, that's the concept that is being tested. It's not x, it's mod x.
Oh, mod. Yeah. Depends
Why?
on depends on sign.
The reason it's mod x is because the convention is that outside square root, whatever, when you do root of something, it has to be positive.
Right.
You don't mean anything negative. It should never be negative. But
Huh.
the x square could have come by being x square or minus x square
Mine.
also.
Yes.
So it could have, if you just blindly remove the root, you could have ended up with minus x, right?
Yes, sir.
But that is not allowed. You have to do mod x so that the value becomes positive.
Hmm.
If you don't you know this concept, you cannot do this question. So basically, the point is that here you will say alpha 1 comma beta 1 will be sec theta plus minus mod of tan theta,
Hmm.
right?
Right.
And now you need to know that this is which quadrant?
This is
Fourth quadrant.
fourth.
Fourth quadrant sign tan will be positive or negative?
Tan is negative.
So then this will break out with a minus tan theta, right?
Yes, sir.
So it will be sec theta minus plus tan theta, right?
Hmm.
So the roots are sec theta minus tan theta or sec theta plus tan theta, right?
Yes, sir.
Sec theta minus tan theta or sec theta plus tan theta. Now which one will be bigger?
Minus tan theta.
Right. So that will be your alpha 1, right?
Yes, sir.
Do you understand what I'm saying?
Yes.
Whichever gives bigger value will be alpha 1. Minus tan theta because that will make it positive, right?
Right.
So this is your alpha 1, this is your beta 1. This condition is there just to help you identify.
Okay.
This quadrant information is there just to help you break the mod correctly.
Hmm.
Exact same thing you have to do for the other one also, right?
Yeah.
You will identify alpha 2, beta 2. That time there will be a mod sec theta.
Yeah. Right.
Do you understand what is happening?
Yes.
If you do everything correctly, you will identify alpha 1 and beta 1 properly, and then you can add them and get the answer.
Yes.
It's a simple conceptual problem, but people will make mistakes here if they write simply x.
Hmm.
Do you understand?
Yes, sir.
So that is something that you can't do.
Okay.
Is it clear?
Yes, sir.
Okay. By the way, like, what is the plan for you? What are you working on right now for maths and physics? How are you working at home?
Sir, for physics, I've been going through the Allen module. They have exercise 5 for previous advanced questions.
Mhm.
So I've been revisiting concepts and trying to solve the questions from that. And
So, which chapters? What chapters have you started with?
right now I'm doing optics. I
Okay.
started with optics.
Why are you starting with optics?
Sir, I wanted to strengthen that so that I'm already good with wave optics, and I want to strengthen ray optics also a little bit.
Okay.
Yeah.
But what about easy? Optics is not the easiest thing to start or the easiest thing that is guaranteed marks. What about the topics that are more easier than that? What is your plan for that?
I was going to move on to modern physics after that. I'm fairly good with those chapters as well. And
Mhm.
after modern physics, I was thinking, uh,
We'll be doing a physics class tomorrow, and you can continue with your order, what you feel is right for you. We'll be starting with thermodynamics.
okay,
Thermodynamics is a easy chapter that needs to be mastered properly. So in our classes, we'll be starting with thermodynamics, then mechanics, and then electromagnetism in this order.
okay,
You can continue with your order because if you feel that they are strong for you, then it is good to strengthen it further. But
so,
do you understand what I'm saying?
yes,
We will start with this, then with this, and then maybe before you can possibly bring electromagnetism in your list. And we'll end up doing fluid mechanics, sound and waves, and those chapters. Fluid
okay,
mechanics, 11th grade chapters, which can be high scoring chapters. Sound and wave on a string.
okay,
So we will stick to this order for now, and maybe by the time we reach here, then we will do at the end electromagnetism.
hmm.
Electromagnetism, like, see, right now it is April 10th. You have 1 month. So 15 days we have. After that, we have to do electromagnetism. So you have 15 days to do whatever you're doing, and we also have 15 days to cover portions of this that are important from the exam,
Okay,
right?
sir. Yes.
So tomorrow onwards, tomorrow there will be a class for thermodynamic stuff,
Hmm.
and again we'll be doing JEE advanced problems in that. That's
Okay.
how we'll revise, by doing JEE advanced questions. Okay.
Yes, sir.
See, we don't have a lot of time, so you continue what you're doing, but we have to do it parallelly and cover up the stuff that is important. The idea is to maximize marks where marks are easy. I would not have recommended optics, but if you feel that it is strong for you, then good, then do it. I would have recommended start with these things: modern physics, thermodynamics. These are much easier. Sound and waves.
Hmm.
But anyway, it's fine. If you have started it, do it. If you feel like it is strong already, then make sure that it is good.
Yes, sir.
Solve all of the advanced questions at least last 10 years, and then you will get a hang of it. Okay.
Yes, sir.
So that is the plan. Do you understand the plan?
Yes, sir.
For maths, what are you doing at home?
Maths, I've been trying to do 3D vectors. I haven't done planes much. I have to revise that topic.
Okay,
And
so this chapter you have started. What is the chapter after that you are going to do?
after that, I was thinking of probability
Okay.
and PNC.
Why are you picking these topics? These are not going to be easy.
So probability, I think I'll be able to do. So
Again, you are picking the most difficult topics, which is not guaranteed. Why are you not doing coordinate geometry? What happened to coordinate geometry? That's 100% guaranteed already okay for you.
no.
Basically, you're avoiding the actually easy chapters and picking stuff that you are comfortable with. This is really easy, dude.
Hmm.
Okay, fine. If you don't want to do it, we will do coordinate geometry in the class. We'll start with coordinate. You can do your order, whatever you feel you have to make it better, but probability and PNC is not a good choice because it is actually tough and questions can be difficult.
Okay.
If you feel like you need to work on it, go ahead, but there is no guarantees on PNC and probability in JEE Advanced. Do you understand what I'm saying?
Yes, sir.
The guarantees are in coordinate geometry, vectors 3D. These are guarantees. Like no matter what they give, if you have prepared properly, you can solve it.
Okay.
Coordinate geometry. That's why we started with chapters in algebra, which are easy if you know what you're doing. Some chapters in algebra are easy, some chapters in algebra are hard. These are one of the hard chapters: matrices and determinants, probability and PNC.
Hmm.
Do you understand what I'm saying?
Yes, sir.
We will focus in our classes. Like right now, we are doing algebra. Once we finish the algebra section, we will go to coordinate.
Hmm.
Once we finish coordinate, we'll revise trigonometry, all the easy stuff, and then we'll do calculus some bits. So obviously after this you should do calculus and integration and different all of the integral calculus parts.
Hmm.
In our classes we'll cover the differential calculus PYQs at least. So my target will be ki at least these things have to be fully finished by the time in 1 month.
Okay, sir.
You work on these topics then.
Yes, sir.
Do you understand what I'm saying?
Yes, sir.
Make sure 3D vectors, planes, and all everything is done. All the previous year's questions you have tried out, you have learned all the required theory. Don't leave anything. This is one of the easy chapters. This is one of the easy chapters. Any question that comes from here should be solved.
Yes, sir.
Same cannot be said for this, for this, for this. They can be tricky in the exam,
Hmm.
but it's fine. You can work on those. You spend more time on those. We will cover all of this in our classes. Okay.
Okay, sir.
Okay, our first target is algebra chapters, which are easy, and then we'll move to coordinate in a few classes. But tomorrow will be physics. Tomorrow we'll start with thermodynamics.
Okay, sir.
Now, here the next question is Let S be the set of all non-real, non-zero real numbers alpha such that the equation alpha x square minus x plus alpha equals 0 has two distinct real roots x1 and x2 satisfying the inequality mod of x1 minus x2 is less than 1. The question is, which of the following which of the following intervals is slash r a subset of S, and the intervals given are option A minus half minus 1 by root 5, option B minus 1 by root 5 to 0, option C 0 to 1 by root 5, and option D 1 by root 5 to 1 by 2. So S is the set of all alpha such that this condition is true, right?
Right.
And you have to find which of these options are subsets of that set.
Yes.
It could be multiple correct.
Hmm. Sir, option C is 0 to 1 by root 5, right?
Hmm. What are the conditions you are trying?
Sir, first of all, for two distinct real roots, 1 minus 4 alpha square is greater than 0. And
So from here you already get a set of alpha, right?
yes, sir.
1 by 4 is greater than alpha square, so minus half to half.
Yes, sir.
Okay, but we also need to satisfy this additional condition.
Right. So when we find the roots, we have root over 1 minus 4 alpha square will be less than 1, or it will be greater than minus 1. So,
One
but
second. The roots are what? X1 comma x2 is what?
uh,
Minus a 1
1 plus minus root
root
of
over
1 minus
discriminant, which is 1 minus 4 alpha square by alpha 2 alpha.
2 alpha.
So when you subtract them, x1 minus x2, you will get what? Let's take x1 is this one plus 1 and x2 is the other one.
Hmm.
So you will get 2 times of root over, right?
Yes, sir.
4 alpha squared by 2 alpha, and we have
Right.
to put a mod on it, right?
Yes.
So you are getting the condition mod of root over 1 minus 4 alpha square by alpha is less than 1.
Yes, sir.
So we just have to simplify this and solve this properly, right?
Hmm.
So we can write it like this, less than mod of alpha, right?
Yes.
And then we can square it. So you'll get root over 1 minus, no, you'll get 1 minus 4 alpha square is less than alpha square, right?
Yeah.
Correct, no?
Yes, sir.
So you're getting 1 by 5 is less than alpha square.
Yes.
So alpha is bigger than 1 by root 5 or lesser than minus 1 by root 5.
5.
And now you take the intersection of this condition and this condition, you will get the answer.
Yes.
So there will be two options, minus half to minus 1 by root 5 and then half 1 by root 5 to 1 by 2.
Yeah.
Those are options A and D. Do
Yes,
you
sir.
understand that this is easy only?
Yeah.
There is nothing difficult about it. You just have to do it properly, right?
Yes, sir.
Okay. The next question is this, the quadratic equation, Px is equal to 0 with real coefficients has purely imaginary roots. Okay. Then the equation P of x is equal to 0 has only purely imaginary roots, all real roots, two real and two purely imaginary, and four, neither real nor purely imaginary. This is a nice conceptual question. First of all, you should remember what we discussed earlier. If there are real coefficients in an equation and it has imaginary roots, then
They are conjugate.
they have to be conjugate pairs, right?
Yes, sir.
So if it has purely imaginary roots, it will be of the form what?
Uh,
Some
A
pi or minus pi,
minus.
right?
Yes, sir.
These are the two roots of, let's say, or we can put it as bi if you want. We can put the roots are bi and minus bi, right?
Yes, sir.
These are the roots of p of x equals 0. So from here you can see sum of the roots is what? 0, right?
Yeah.
And product of the roots is what? Product is minus b square I square, so b square, right?
Yeah. Yes, sir.
It will be a positive number, right?
Yes, sir.
So we can write the equation as x minus 0 times x square minus 0 times x plus b square, right?
Right. Yeah.
Something like this, right? The equation
Yes, sir.
x square plus b square type of, this is the type of polynomial you will end up with, right?
Yes, sir. Right.
Right. So now we just have to figure out what will happen if you do p of x, right?
Right.
So our polynomial p of x is x square plus b square if we had chosen the roots as this, right?
Hmm.
Correct.
Yes, sir.
So let's think about p of x. We want to check whether what kind of roots that will have. So it will be uh, p of x square plus b square, right? So that will be x square plus b square whole square plus b square, right?
Yes, sir.
Correct. So that will become x power 4 plus 2 b square x square, right?
Yes, sir.
Plus b power 4 plus b square, right?
Hmm.
Right. This is my thing. Now, obviously, looking at it only, you should decide that can it have any real root? This fourth degree polynomial, can any real number make it 0?
No, no.
That's impossible, right?
Yes, sir.
Do you realize why?
Everything
Because
is positive.
everything is even powers, no, and everything is positive.
Yes, sir.
So this option is gone, this option is gone,
Yeah.
right? So only thing we have to decide is this option and this option, right?
Yes, sir.
So now we should check whether a purely imaginary number can be a root of this or not, right?
Yes, sir.
So let's check like some p of I, some random purely imaginary number, right? So what will I get? P power 4, I power 4. So p power 4 plus 2b square, p square I square. So minus p square plus b power 4 plus b square, right?
Right.
Correct.
Yes, sir.
Uh, so maybe I should have checked with the same roots as these, right? Because it is possible that the roots of the original equation could be roots of this, right?
Right.
So it would have become b power 4, right?
Yes.
B power 4 and
Plus.
minus b square here, right? So minus 2b power, okay, so notice that that is not a root
Huh.
because b power 4 and b power 4 will cancel this, but it will not cancel the plus b square, right?
Yes, sir.
So these original roots are not roots of this new one, right?
Yes, sir.
Okay. Uh, in general, uh, original roots are not becoming roots of this. So 1 second. So if you think about it, okay. okay, we can give a logical answer for which option will be coming. So think about it. Uh, we know the type of polynomial we have, right? X square plus b square, right?
Yes, sir.
Now, let's say we know that p of x equal to 0 has no real roots, right?
Right.
We know that already. Now, suppose we have p of x. Let's assume for now that it has purely imaginary roots.
Hmm.
Has purely imaginary root, right?
Hmm. Right.
So, uh, if some purely imaginary root is there, then what is the value of p of x if you put x as some purely imaginary stuff, right?
Right.
Think about it. Uh, if you put x as some purely imaginary stuff, p of x is going to be square of that plus b square, right?
Right.
Think of putting a purely imaginary number inside it. It will become real, no, this part.
Yes, sir.
And b square is anyway real, right?
Yes.
So what we are getting is when you put a purely imaginary number inside p of x as input to p of x, you end up with a real value of p of x, right?
Yes.
Do you understand what I'm saying?
Yes, sir.
P of x has become real, right?
Real.
But if you input a real number inside the p here, is it ever going to be 0?
No, because it won't be
No,
real.
because we said already px doesn't have real roots, right?
Real. Right.
So the point is that since this is a composition of two things, right? When
Yes.
you put x as a purely imaginary number, it is guaranteed to become real because of the way p of x is, right?
Yes, sir.
However, if p of x was a regular quadratic, it would not be guaranteed to be real, no, if you put x as purely imaginary, right?
Yes, sir. Right.
But in this case, it is guaranteed to be real, right?
Yes.
But since now the p of x value has become a real number, that cannot make the outer p become 0, right?
Yes, sir.
So we have proved that this will never happen, right?
Hmm. Right.
P of x can never have purely imaginary roots. Do you
Hmm.
understand why?
Yes, sir.
We have also earlier proved that b and c cannot happen, real roots cannot happen.
Yes, sir.
Because we saw the nature of p of x, it became something like a fourth degree thing with everything positive, right?
Positive.
So that's why these three options are gone. So it is neither real nor purely imaginary. So it must be some complex numbers,
Yeah.
regular complex numbers, right?
Yes, sir.
It cannot be purely real or purely imaginary, right?
Hmm.
Are you understanding?
Yes, sir.
So this is like a good question, which is conceptual, no calculations, but it requires some thinking.
Yes, sir.
This is JEE Advanced 2014. Okay. The next one is this complicated looking question. Find the value of 6 plus log 3 by 2, 1 by 3 root 2, square root of 4 minus 1 by 3 root 2, square root of 4 minus 1 by 3 root 2, and square root of 4 minus 1 by 3 root 2. You have to find the value of this expression.
Okay.
Oh, actually, this continues forever, actually. That makes it much easier, by the way.
Yeah, that makes it easier.
This continues forever. If it was finite, then it will be much harder.
Yeah. Sir, 4.
Okay, it's simple only. There is no need to discuss anything here.
Yes.
Uh, the next question is value of B. Okay, I'll write the next one or two questions. Value of B for which the equations x squared plus bx minus 1 equals 0 and x squared plus x plus b equals 0 have one root in common. And the options here are root 2 minus I root 3, I root 5, and root, this is minus root 2, I think. That is the first one. The second one is let alpha and beta be roots of x squared minus 6x minus 2 equals 0. Alpha is greater than beta. If an is equal to alpha power n minus beta power n for n greater than equal to 1, find a10 minus 2a8 divided by 2a9. This type of question you have already seen before.
Hmm.
Smallest value of k for which both roots of x square minus 8kx plus 16k square minus k plus 1 is equal to 0 are real, distinct, and have values at least 4 is what? So try these three questions. You have around 6-7 minutes. After that, we'll discuss. I'll be back in 5 minutes. Okay, just try it out.
Yes.
Okay, so first one, have you got anything?
Um, almost. 1 second.
Mhm. It's a standard question based on the standard method for doing common roots.
Yes. We take some common root alpha,
Hmm.
put in the equations.
Right, and you have to solve for alpha and solve for alpha square separately,
Yes.
and then equate the two and eliminate alpha.
Hmm. So option B.
Mhm. Okay, that is correct.
Yes.
You should get finally an equation like b square b cube plus 3b is 0.
Yes, sir. Yeah.
And then you will say that the roots are 0 or plus minus root 3i.
Yeah.
0 is not in the options, so you will say minus I root 3.
Yes.
So this standard method you should know, right?
Hmm.
So the method is simple. Solve for alpha square. So for alpha square, I will eliminate alpha term. So for that, I will have to multiply by b here and subtract, right?
Yes.
So you will get an expression for alpha square. Similarly, solve for alpha also. For that, I will eliminate alpha square.
Alpha.
So then I don't do anything and subtract simply, right?
Yes, sir.
I'll get a something for alpha. Then use this alpha and use this to say that this square should be this, right?
Yes, sir.
That will give you the condition. You don't have to try to memorize the condition. Don't memorize it.
Hmm.
You just have to do this in the exam properly.
Right.
Okay. Next one is next one we have done several questions like that now. It should be doable.
Yes.
You need to get a relationship connecting A10 to A9 and A8.
Right.
How will you generate a an term? We have two valid equations. What should I do?
We have to multiply by
Hmm.
alpha n power minus 2.
Hmm. If you multiply both the equations like this, you will get alpha power n minus 6 alpha n minus 1 minus 2 alpha n minus 2 is 0. And similarly, beta power n minus 6 beta n minus 1 minus 2 beta n minus 2 is 0, right?
Right.
If you subtract them now, you will immediately start getting what you need, right?
Hmm. Right.
Alpha n minus beta n is a n minus 6
6
a n minus 1, right?
and
Minus 2 a n minus 2, right?
yes.
So immediately we get an expression like this. So we can see this form here, an minus an minus 2 twice, right? So we just keep this and this on this side. So we know an minus 2 an minus 2 is equal to 6 an minus 1, right?
Yes. Right.
So this top part is basically 6 a9.
Right.
Answer is 3. Do you understand? This method is general. This is what you need to do in such questions. Try to create your an, right?
Yes, sir.
Remember, there was a question again that was asked, which was P alpha n plus Q beta n, right?
Yes, sir.
We just made equations like this, multiplied by P, multiplied by Q, and added it to create an.
Yes, sir.
So that is a standard method in these types of problems. Okay.
Okay.
The third one is doable. You should do it yourself. I think you will get the answer. There is no issue here. The roots are at least 4. So both the roots are greater than equal to 4.
Hmm.
So it's a question on location of the roots. Roots are real and distinct, so discriminant is greater than 0.
Yes.
So you can try it out. Uh, Tomorrow's class will be on physics and we'll be doing thermodynamics questions. And day after tomorrow, we'll be doing maths. And that would be starting sequence and series.
Okay.
The quadratic, more or less, we have covered all the types of questions that come. There are one or two questions left, but you can find them in your. Mostly, we have covered the last. This was the question that we are last looking at is JEE 2009. So all the other questions we have already done.
Okay.
So we will go to the next chapter, which is sequence and series, and then after that we'll do complex numbers, binomial, these chapters.
Right. Okay.
Once we finish our basic algebra, we will move on to coordinate.
Okay, sir.
So tomorrow we'll start with physics, thermodynamics. You continue with whichever chapters you have planned out. You do it at home, do the PYQs, read the theory, make them better. And we will try to cover some PYQs in the classes for the other chapters.
Yes.
Okay, fine. That's all for now. I'll see you next time.
Thank you, sir.